Hello students, in this video we are going to see one more example of resultant of parallel force system. Let us see the statement. Three parallel forces act on the rim of a circular cover plate as shown in figure. So it is a circular plate whose radius is 0.8 meters and three forces 150, 300 and 200. Three forces are acting on the rim of this plate. So determine the magnitude, nature and the point of application of the resultant force with respect to the origin. Means you have to find out the magnitude of resultant, nature of resultant, whether it is acting vertically downwards or upwards, and its position with respect to the origin O. Here it is given x, y-axis and a vertical z-axis. Let us assume that the resultant is acting at this point at a distance x meters from y-axis and at a distance y meters from x-axis, right? So it is the resultant. So initially we are assuming the position of resultant. It is in the first quadrant. I mean in the positive x and y quadrant. It is just assumption. Okay. Now we know that being all the forces are acting along z direction, algebraic sum of all the forces in z direction gives you the resultant. So you can write summation Fz is equal to R, which is equal to minus 150 minus 300 and minus 200. So you will get R is equal to minus 650 Newton. So it is 650 Newton acting vertically downwards. So what is the magnitude of resultant? 650 Newton. Direction of resultant? It is vertical. Nature of resultant? Acting vertically downwards. Now to find out the position, we will take moments about x and y axis using Varignon's theorem. So to find, say, y, to find distance y, we will take moments about x axis. So taking moments about x axis and using, yes, Varignon's theorem. What is Varignon's theorem? Algebraic sum of all the forces about x-axis is equal to moment of resultant of those forces about x-axis. Now see, the radius of the plate is given 0.8 meters. So in the figure you have this as y-axis, this is x-axis and z-axis is vertical. If we take this xy horizontal plane, so z-axis is vertical, perpendicular to xy plane. Now this 150 Newton is acting at this point, 150 Newton. And if we join the origin and the point of application of that force, that is making 45 degrees, right? So what is the horizontal distance of this point from x-axis? This radius is 0.8 meter and it is 45, so adjacent side 0.8 cos 45. And how much is this distance? Opposite side 0.8 sin 45. Okay, because for taking moments of this force we need these distances. Now taking moments about x-axis. What is moment of 200 Newton force about x-axis? this 200 Newton is acting on the left hand side of x-axis downwards. So it is creating anti-clockwise moment. So we will consider anti-clockwise moments are positive. So it is plus 200 into what is the perpendicular distance between this 200 Newton force and the x-axis? That is nothing but radius, 0.8 meters. See, the 200 Newton force is acting at this point. So 200 into the radius of the plate, 0.8, and it is forming anti-clockwise moment. So it is positive. And the moment of this 300 Newton about x-axis is 0 because 300 Newton is acting on the x-axis. So it is acting at this point. So its moment is 0. And the moment of 150 Newton about x-axis, now this 150 is on the right hand side acting downwards. So it will create clockwise moment. This 200 Newton is on the left hand side acting downwards. It is anti-clockwise moment. And that 150 Newton is on right hand side acting downwards. It is creating clockwise moment. So it is minus 150 into what is the perpendicular distance? Perpendicular distance from the line of action of the force to this point, that is the origin, that is 0.8 cos 45. 0.8 cos 45. This must be equal to the moment of resultant about x-axis. Now see, we have assumed that resultant is on the right hand side of x-axis and it is acting downwards, so it will create clockwise moment. So it is minus magnitude of resultant is 650 Newton. So it is 650 into perpendicular distance is y. Solving this equation, you get y is equal to minus 0.1156 meters. This minus indicates what? We have assumed that the y is positive. It is on the positive side. But we are getting negative. That means this y is negative side. So this point is on the left hand side of x-axis. Right. Now to find out distance x. To find distance x, you are to take moments about, yes, to find out this x, you take moments about y-axis. So taking moments about y-axis and using Varignon's theorem. Now we are taking moments about this horizontal line, that is y-axis. So moment of 200 will be 0 because 200 is acting on y-axis. And the moment of 150, see this 150, suppose if you take this as y-axis, 150 is acting on the right hand side downwards. So it will create clockwise moment. Whereas if you see this 300, it is on the left hand side and it is acting downwards. So it will create anti-clockwise moment. So about y-axis, moment of 150 is clockwise. So it is minus 150 into the perpendicular distance. Perpendicular distance is 0.8 sine 45. 0.8 sine 45. And the moment of this 300 is anti-clockwise. So it is plus 300 into perpendicular distance, nothing but radius, 0.8 is equal to moment of resultant. Again this resultant is on the left side of the y-axis and it is acting downwards. So it will create, yes, it is anti-clockwise moment. So it is plus magnitude of resultant is 650 into distance is x, perpendicular distance. Solving this equation, you get x is equal to 0.238 meters. So we are getting x value as positive, y as negative. So x is on the positive side, y is on the negative side. So the position of resultant will be somewhere here. We have this as negative y plus x. 0.238, that is plus x, and y is 0.1156. So this is the position of resultant. Understood?